So, Venkat, thank you so much for joining me on the Inductive Economy. It's an absolute pleasure and a privilege to have you on the show.
Hello, Vignesh. Yeah, it's really my honor and my pleasure to be with you.
So, Venkat, let's start off at the very beginning. So, what was it like for you during your days at IIT Delhi? You're a distinguished alumnus of the institute, and how did your experience at IIT Delhi really shape your interest and decision to pursue a direction and a career in computer science?
Right. Yeah. Thanks for that question. I finished my schooling in the late 80s, and I entered college at IIT in at the end of the 80s, 1989, and that was a time when the world was not nearly as well connected as it is today, right? So the information you got was really from talk to people and maybe reading some physical books and so on, right? Uh, yeah, at that time, and I think it's still the case that the IITs had a special position, a special place in the Indian ecosystem in terms of higher education, and so it was a natural goal for me to sort of aim for IITs, and there was also a sense that computer science is a booming discipline, right? It was still in the early days, but there's a lot of potential. So in some sense, that's really what got me into computer science and IIT. And once I got there, the combination of the institute, the great faculty, and also a very strong peer group is what really pushed me to, you know, excel and aim high, right? So that's really what provided me the foundation.
Yeah, and during your stay there, you like you said, the faculty, the peer group, the environment, it must have motivated you to pursue your graduate studies in my, if I were to assess it correctly. So, how did you decide to go to Berkeley, and how was the environment there, and how did that influence your research interests?
Right, right. So yeah, there again, actually for the longest time, I would say even from high school days, I developed a deep interest in science and technology and so on. Right, it's just again from reading and idolizing scientists and so on. It seemed just like something that I would enjoy because of the freedom science provides just to think, to create new ideas and so on, right? It's very different from what you might think of as a routine job, right? So that's what really inspired me to go for higher studies, because higher studies is a way, is a stepping stone, almost a required stepping stone to get into a career in doing research and so on. As far as Berkeley is concerned, like many of my peer group, we applied to graduate school, mostly in the US, because the US was and perhaps still is the place with the strongest set of research universities in the world. And I was quite fortunate to get admitted to Berkeley, which is at the very top on the handful of really top universities, not just in computer science, but across disciplines, right? Across engineering and even beyond engineering. Right, it's really one of those special places. I also actually happened to talk to an alumnus of Berkeley, a senior of mine from several years, and I should thank him for setting me to pick Berkeley as the place, because I had a few other choices, and he said, go there, and that was a great piece of advice. And being in Berkeley in the 90s, which is when I was there, was a great time, because that's when there was a lot of action happening with the internet boom and so on, and I was kind of in some sense at the right place at the right time, and so that was good.
So I just want to take it back one step. There's something really interesting that you said, that science has always inspired you as a kid when you were young, right? And you were talking about reading physical books about it. So can you talk to me a little bit about what are those books that really left a lasting impact on you from all those years ago?
Right, right. So actually, my parents always sort of valued education a lot. So they, uh, you know, essentially invested in these physical encyclopedia sets, right? So we had a 26 volume, general encyclopedia, and a 6 volume encyclopedia on just science and technology. It was called, I think, I forget the exact name, something on popular science, right? It's 6 volumes, and I don't recall the name right now. I still have it. In fact, I have a newer version of it in my home now. I don't read it as much anymore. It's just there in the showcase. So I think those, they're attractive books that you sort of can read, but also look at pictures, and you get a sense. The other thing is, I was into reading biographies, right? So I read several biographies of Einstein, who I used to idolize. I Uh, my older sister, who was 3 years older to me, when she was in 11th standard, she was studying calculus, and I picked up her book one day and I taught myself calculus in the eighth grade, right, in eighth standard, and it was so natural and so intuitive that then I started sort of solving problems on my own, right? So things like that, right? So essentially, it was just curiosity that sort of made me go beyond what was in the school curriculum and just sort of read and get inspired. So I would say, any kid who's looking to expand the horizons. Of course, today there's a lot of content online, so you definitely leverage that. But really read and really immerse yourself in high quality content. I think that will really inspire you.
Understood. And could you also share how your mentors, like Professor Randy Katz, impacted your approach to research during your PhD? What is that experience like?
Yeah, I can certainly do that. Actually, I should even start with IIT, right? So, in IIT also, I had the opportunity to do, small projects. Maybe they're not major research project, but actually, my first paying job with was in the summer of 1990 at a lab run by Professor M. Balakrishnan and Professor Anshul Kumar on essentially uh, computer aided design for ECAD, electronic computer aided design, right, for electronic circuits. And that was a very interesting experience. It was also my first paying job. Actually, got paid for it, and so that really gave me the confidence to uh, do things that were do things with my hands and do things that are beyond the typical textbook curriculum. When I got to Berkeley, actually, interestingly, I didn't work with Randy Katz initially. I went there at a time which was interesting. It was quite challenging. It was 1993, and because of economic reasons, the University of California system decided that they need to save money, right? So they had a bunch of senior professors take retirement packages and essentially leave, right? So the first year I was there, I didn't really have an advisor. But what nice thing that happened is at the end of the first year, I did an internship, and that internship really was on actually HTTP, which is the protocol that underlies the World Wide Web. The World Wide Web was 2 years old, and it was very early days, and I was able to do an interesting piece of work on improving the HTTP protocol, right? And that work even today is part of internet standards, right? That gave me a lot of confidence, and that led to my master's thesis with a different professor called Domenico Ferrari. And then Randy Katz, who was actually out visiting the White House for a couple of years, right? He actually wired up the White House in the U.S., right? The president's
Yeah.
home and residence there. He came back to Berkeley in '95, and that's when I connected with him. And I really liked his. He was a senior professor, well established, well connected, and interestingly, he was trying to move into computer networking, which was new to him as well, right? So in some sense, he was a well-established professor who was as new to the field as I was, right? So in some sense, it was an interesting experience because it gave me and some of my fellow students a lot of freedom to explore, right? Because you have a professor who is sort of also sort of learning with you, right? And that sort of gives you freedom to explore, make mistakes, learn from mistakes, and so on. So that was really good. And Randy was inspiring in other ways. He had a good sense of the big picture, sort of what is important, presentations, and also how to sell your idea to others and get funding, right? As a research group at a university, you have to get funding, and so I learned a lot of these things beyond just the technical work from him. But I really must thank him for that.
Yeah. And your PhD is winding down. It's about time you're entering the professional world. So there is a decision that you have to take. So at what point in this process did you really consider a career in research? And what was that one pivotal moment, or what are those series of events that basically said that, hey, I think this is what looks right. I think if I were doing research for the rest of my career, whether it is in academia or whether it is in in industry, I think this is what I want to do. How did you sort of zero in on that?
Right, right. Yeah. So I must be honest, right? I mean, I wouldn't say it was a very deeply thought decision. It was not. I was not like, oh, I have to do research versus this. It just came to me naturally, right? Because in some sense, I was immersed in this research university, Berkeley. I did a couple of internships. One at Bell Labs, which you probably heard of. Another at a lab which actually was also in its heyday was very well known. It is a company called Digital Equipment Corporation. No longer
Yep,
exists,
deck.
but
Yep.
yeah, and they had a lab, and in fact, a lot of the alumni of that university, or not of that lab, went to Google in the early days. A guy called Jeff Dean, and a bunch of
Yep,
people.
of course.
They all were at that lab where I was, right? So those research internships also gave me a sense of what the life of a researcher is, and the fundamental point that struck me is in research you're out there creating new knowledge and creating new ideas and making new ideas real, right? You're not doing something routine where someone has defined an agenda and you're just executing on it. So in some sense the freedom and the freedom to explore is what inspired me, and so it was very clear to me that that's what I should be doing now. Sometimes I wonder maybe I could have done something different, maybe, and maybe I would have done well or not, I don't know, but in some sense you get one shot in life for doing something, but I'm very happy with the choice I made. One thing I would say is go with what you feel excited about, right? In some sense that is the single most important thing, right? The world may have its own views, and others may be doing something. There may be a certain herd mentality, like everyone's doing this, you're doing something different. Don't ever be afraid of doing something that really inspires you, right? I think that's something that I've tried to follow. Even in my selection of research projects and research topics, I've tried to go with what inspired me and what made sense to me, rather than going with the herd. I mean, sometimes and rather often the herd may be right, and maybe what you want to do in that sort of overlap, and that's great. But being able to think for yourself and being able to have confidence in your judgment, I think, is pretty important, right? And that's something that I've learned over the years, and really, I think, has served me well.
I think that is super interesting because a part of having that satisfaction and taking that path is understanding whether the scope and scale of the problem that you're trying to solve or you're pursuing is worth the effort, is
Yes.
worth the
Correct.
quest, is
Yeah.
worth that journey. So I'll just take a detour and just discuss about how do you really think about problems, right? So I think one of the interesting things about technology is that I think a large majority of people view technology as a solution to problems.
Yes.
But technology is actually a lens through which you're able to assess problems more accurately or
Yes.
more intimately or more divergently, is how I would sort of frame it.
Yes.
So, in your estimation, what is a good problem? How do you define a good problem? And how do you know that I think this is a good problem to take and this is a good problem to work on for X number of time? Or how do you define that process?
Got it. Okay, I think that's a great question, and obviously there's no easy answer here, but I'll give you my perspective. Right. I think I would say maybe this in two parts. Right. First is there are problems. There's a class of problems that exist, whether technology exists or not. Right. The need for communication, like what you and I are doing today, 30 years ago, perhaps didn't exist. And I say 30 because I was in Berkeley when some of my colleagues were creating the early versions of
Yeah.
what became things like Zoom and Teams and so on, right? It didn't exist. The need for communication is sort of a human need. Technology may not have been there for a long while, and then technology came and so on. But there's a second class of problems that arises from technology itself. Right? Essentially, uh, as you look at technology trends and sort of what's coming down the road, and sort of what the future is going to look like, and what the needs, the new requirements, the new needs that will arise from that future, then there's a set of problems to be solved. Right? So in some sense, as a researcher, I've tried to combine both of these. I'm not necessarily in equal measure all the time, but essentially keep an eye out for things that uh, are sort of inherent problems and some things that arise from technology. I would say over time the latter perhaps starts dominating, because the basic problems, the needs sort of get satisfied, right? People sort of have electricity, and they have water and this and that. But I'll just give you an example. Maybe it's sort of specific sometimes are easier, and maybe I'll talk about one of my current projects. Right, it's a project called HyWay, which is around hybrid interaction. Really, the impetus for this was really in the second month of the pandemic. Right, like everyone, I was stuck at home, and at Microsoft Teams is our go-to tool for conferencing, and that was my lifeline to connect to my colleagues and connect to others and so on, even family. Right, I mean, I would do team calls, and it's a great tool, as a Zoom and the others, but it's very isolating. Right now, you and I are having this conversation. It's not on Teams, but it is something similar. But we know nothing about the rest of the world, and the rest of the world doesn't know we're talking. Now, of course, we are recording a podcast, so we don't necessarily want people butting in. But the point is that if you are having a casual chat, also, there's no visibility, right? So the idea that, hey, we're going to be in a hybrid world. The pandemic has fundamentally changed things. We're going to be in this hybrid world, and the hybrid world will have new requirements, is something that I started thinking about. In fact, I wrote a memo in April 2020 and sent it to a bunch of people saying, hey, we need to rethink things. And, that eventually led to HyWay over the next couple of years. So that's an example, and I'm happy to sort of talk more about HyWay later in our conversation. But that's an example of something where there is a new need that arose because of the change in the world, which was the pandemic and the isolation, and the limitations of technology. And so I could see an opportunity for doing something new and interesting. Right. So I think that's really how things work. There's no one formula, but I think keeping your eyes open, reading widely, being broadly aware what's going on, I think those are important ingredients to being able to pick good problems.
Right. No, absolutely. And in fact, this has even spurred me into another line of questions, if that's perfectly all right with you, which is you have a problem. I think we've defined how do you seek problems right now. The second step is what are the principles of design to actually tackle that problem, to actually identify what the right solution is, right? So you have those principles in place, and then you identify that, hey, to design a solution for this, it needs to be criteria A, B, C, whatever that might be, however you might, filter it out.
Correct.
Number three is you craft a solution for it and then you test it out. And then you test and fix, you test and iterate, you test and iterate till it keeps improving, right?
Yes.
I think the solution is largely, I think the framework is largely this. But can you talk a little bit about that design phase where you decide that this is the basic extension of how I want to tackle, or I want, see, the thing is, I think there's a great phrase that said that problems worth solving show their worth by fighting back, right? There's a lovely phrase that I read somewhere, I don't know.
Right.
So do you take something like, during pandemic times, how do you really ensure that you are connected and you're collaborating
Yes.
more effectively, more intimately?
Yes.
You need to have those principles in place to see how the problem responds back to you before
Yes.
you craft a solution, right? So can you talk about that?
Yeah. No. Again, a great question. Yeah. So, yeah. So let me share some thoughts here. Right. So I think the first thing, especially in a technology field, right? Pure science is different. In pure science, you're trying to discover how the world works, right? So that's different.
Right.
With technology, you're actually trying to create a new reality, right?
Yeah.
So I would say a key ingredient is, okay. First, you recognize, okay, there's a problem, there's a gap, something to be solved. The second step is to imagine what the future will be, right? What is it that if you if your technology is successful, what is the future experience, or the what is the future reality going to be, right? So, for example, in the context of HyWay, since I picked that as an example, the idea was that I should be able to walk around in a hallway, but completely virtually, and be able to bump into people and be able to have ad hoc conversations. And while having the conversation, I should be able to see who else is around. I should be able to overhear bits and pieces of what they are saying, so that if I see someone interesting or hear something interesting, I can leave this conversation and go there, right? And so, right? So that was kind of the mental model that I created for myself, right? And then I was able to sort of convey to others and inspire others, saying, "Hey, yeah, that sort of mental model makes sense." Right? So that's sort of a key step. The second, of course, is then what are the sort of technology elements, in computer science, the algorithms. I mean, those are sort of details, right? No, actually, even before I get to algorithms on, I think that sort of detail. In terms of technology element, the second thing that is quite important is to then figure out what are the constraints you want to work with, right? So, engineering is really about solving problems within constraints, right? If you had unlimited amount of money, you might solve it one way. If you're aiming for something that can go mass market, you obviously have to worry about cost. You have to worry about ease of use. You have to worry about deployment strategy, right? So if you need someone to install a new app, well, that's a barrier, because people are not going to install your app just because you created one. So if you can just have something that's a browser based thing, that's even better. If you have something that requires a headset, that'll be great experience. You can't beat that. But then you require a headset, which is cost and also an imposition, right? I can't imagine doing a 1 hour conversation with you with essentially a fairly heavy headset around my face, right? It will not be comfortable. So you have to decide. And by the way, there's no one right choice here. There are many points in the design phase that all make sense for the I don't want to use the word market because that sounds like very much commercial, but for the target audience, for the target use case, right? So you have to decide for yourself what you want to do. And invariably in my work, perhaps just inspired by my location here in India, and I want to go for things that are simple, low cost, and easy to scale, right? things that don't require specialized hardware, things really that work with commodity hardware, right? But again, it's not the only choice you can make. You can make other choices too. But anyway, once you've made that choice and you imagine your future, then you sort of then work out, okay, what are the technical bits you need to make that real, right? Sort of how do you design the system? How do you sort of then you have to sort of get to the code and so on, right? So I would say those are the three things, right? Four things, I guess. First, identify a problem, imagine the future, decide what the constraints and the sort of context in which you want to solve it is, and then actually come up with a solution, which I'm not saying is easy, but the last part is something that once the others are in place, you more often than
It
not.
sort of becomes emergent. Yeah.
Yeah, correct. Exactly right. There are challenges. I mean, it's not like everything that you imagine can be built. So,
Yeah. No, agreed.
but then, yeah. So that's the other thing. There is a feedback in the sense that, and in fact, that's something I learned with my PhD from Randy Katz, which is you invent and you build, you experiment, then you have to go back and
Yeah.
adjust your invention because you may find out that things don't quite work the way you hoped it would. So you have to sort of change things a little bit.
You have to recalibrate your assumptions, right?
Yeah. And sometimes your goals too.
Yeah, your goals too. Exactly. Yeah.
Maybe what you'd imagine was like a little too impractical. Maybe you have to do something different.
Absolutely. So I think we've touched upon HyWay twice. Let's dive into that. So I'll go back to that design point. That the one thing that really stood out to me, because I am super passionate about that particular piece, is that there were three design principles to HyWay, which is porosity, reciprocity, and map-based interface.
Yeah.
I thought now there are many things that brings it together, but somewhere I felt that if these three things weren't at the center, I think that experience would not make sense both theoretically and from a user experience standpoint. So can you talk about how did you come to these three principles and how they actually guided you in the solutioning process?
Yeah. Okay. Yeah. So thanks. Yeah. So I think I touched on this briefly earlier, but the starting point for me was the mental model, right? For me, as a researcher, I go to conferences. In fact, I used to do a lot more of that before the pandemic. I think since the pandemic, things have been more online. But going to conferences, meetings, and so on, and rubbing shoulders with others, right? And a big part, a part of the conference obviously is the lectures or the talks, right? Someone stands up on the stage and gives a talk, and people in the audience listen, and usually at the end they raise their hand and ask questions, right? That is what I would call as a structured part of the interaction, structured part of the event of the conference, right? And there, I think tools like Teams do a fine job, right? Because you give a lecture and 100 people, 1,000 people. But then a significant part of the value of going to a conference is not the lectures, because the lectures are recorded, you can watch them anytime, anywhere, it's not a problem. Is actually the informal interactions you have in the hallway, during the coffee break, at the lunch table, and that's when serendipitous interactions happen. You meet someone, either someone you have known for a long time, you're meeting them after a while, or someone new, or new ideas get sparked. I mean, so my mental model was I want to recreate that kind of an experience in this online or hybrid world, right? So then the question was, what are the elements that make this physical conference or physical setting special, right? The number one thing I would say is awareness, which is going back to my earlier point. When I'm in the hallway or at the lunch table talking to someone else or three other people, I can still look around and see someone else. I can see Vignesh is there. Hey, Vignesh has arrived. Maybe I can even overhear a conversation, or maybe I can see that you're talking to someone who's actually more interesting than the people I'm talking to. I can somehow excuse myself and go there, right? So that all comes from awareness. So the question then was, how do we provide awareness? So awareness comes from two forms. One is visual, looking around. Now, again, going back to my constraints. Now, we don't want we could have created an immersive 3D environment. It would be great, that I could actually look around, but that's expensive, right? So we have a simple computer screen. How do we create visual awareness there? Well, a map interface seemed a natural way, right? So essentially a map with sort of face bubbles showing faces of people around, right? The other form of awareness is oral, from audio, being able to overhear not just specific other words being spoken. It's not like we want people to be able to eavesdrop, but if someone laughs loudly or you hear a general buzz from a certain direction, you have a sense that there's something interesting is happening there, or people start clapping there, or something interesting happened there. Let me go there and see what's happening, right? So that's where porosity comes from, right? The third element, which I think really is what makes the physical setting really click and makes people very comfortable. In the physical setting, you and I might be in a crowded hallway and we might be talking some very sensitive stuff. And we are comfortable doing that because we know that the person with respect to whom this is sensitive is far away. There's no way they're going to find out. And if that person starts walking towards us, we will change subject, right? We'll start talking about the weather or something, right? We'll switch to something else because that comes from awareness. So now that happens because that person can't hide himself or himself or herself, right? If that person is coming, you and I can see that and be aware of that happening. So that's where reciprocity comes from. So unlike a large Teams or Zoom call where you could be a passive participant, turn off your camera, turn off your microphone, and just be listening, which is okay for a lecture because a lecture there's a dominant speaker, the professor or the lecturer is speaking. In an informal interaction like this, it would be pretty disconcerting if you and I were talking and suddenly someone popped up that we didn't even see before because they had their video off and we didn't even know they were around. I mean, the map is there, but we'll not be looking at the map all the time, right? So that's where the principle of reciprocity came, right? Idea is very simple. See and be seen. If you want to see, you have to be seen. If you want to listen, you have to be heard, right? So you can't sort of mute yourself and turn off your camera and participate. And if you want to do that, I mean, you can step out of the hallway. You can leave to take a phone call or whatever, and then you can come back. You can't say, "Oh, I'm going to be listening and all the spying on these people," but not let them see me, right? So those were the principles, right? And uh, I thought about these in the early days. I talked to my colleagues. They thought it made sense, collaborators. And then the running joke is that these principles have become so entrenched now. It's like my way or the highway kind of thing, right? So in some
Yeah.
sense, I don't want to let go of these very easily, right? Because in some sense, these to me are fundamental to the experience we are trying to create, right? Often people who've used highway tell us, "Hey, why don't I have a mute button? Why can't I turn off my camera?" You have to explain to them that yes, by all means you can step out of highway and come back, no worries. But if you want to engage, we have to enforce reciprocity, right? So anyway, so that's really
I
uh,
think
yeah,
I think that is super fascinating because the one thing that really caught my attention was your reference to those murmurations that you hear when you're in an environment and then there are seven other, eight other people who are having discussions.
yes,
Part of the naturalness of being in a physical environment is being attuned,
yes,
like you're giving a certain percentage of your attention to those murmurations.
yes,
You and I might be talking, but my ear might be like, trying to pick something up from there,
yes,
right?
yes.
And I think how do you end up modeling those? That becomes very, very interesting because, yeah, for sure, there's audio that's being generated, but getting it at the right strength, right frequency, right amplitude, right weight, that gives you that sense of naturalness. I think, how did you? I'm very fascinated to know how you simulated that.
Yeah, yeah. So we start simple. Essentially, what we did was initially. So there are two aspects to this, right? One is the strength of that audio, how loud it is. The second is the direction it seems to be coming from, right? Initially, you focused on just the former, just the strength, right? We basically came up with a relatively simple way of doing distance-based attenuation, right? If the other conversation is happening far away from where you are in this sort of space, then we attenuate it more compared to a conversation that's happening closer. Uh, but over time, we've also added direction. So there's this notion called spatial audio. We didn't invent it. People use spatial audio for gaming and other aspects. So we integrate that also into highway now, so that you have a sense also of where the sound is coming from. Is it coming from your left or right? Or so the realization for us is that see, there's a lot of research on getting the what's something called the head related transfer function, I think, HRTF, which is really sort of modeling how audio that's coming in gets transformed and gets actually sort of registered by the human ear, right? uh, and there's a lot of sophistication there. A lot of these sort of headset things do these things. But what we found is that these two simple things, doing appropriate attenuation and then to a lesser extent getting the direction right, gives people most of what they want. and without any headset or anything, we are able to recreate the buzz of the physical setting. Oh, by the way, the other thing I should say about highway, I kind of missed that, is fundamentally it is hybrid. The idea is it is set in a physical space, right? So there is a physical space, and what you're doing is you're bringing in remote people into that physical space, right? So the physical space already has a notion of distance and what is far away and what's nearby and so on. So we are able to sort of uh, recreate those things for remote users using what I just mentioned, distance-based attenuation and getting direction and so on, right? And it's, as I said, just doing those simple things has worked very well. I'll just give you one anecdote. A year ago, or actually a little less than a year ago, our CEO Satya, last January, was visiting. Satya Nadella was visiting, and as a lab, we are based in Bangalore. We had 45 minutes of his time, and he's a busy guy. But we got that time while he was in Hyderabad, right? So he could not physically come here to the lab when he was in Bangalore. So our choice was just to do a Teams call where a couple of us would go there to meet him in person. The rest of the team would be here, and we'd meet him on Teams. But we said, okay, let's just try HyWay, right? So we basically used HyWay to allow him to walk around the lab and sort of visit the lab, right? And one of the first things he noticed was like this buzz, that that fact that he's able to see other people around and hear other people around, and that really caught his attention. So in some sense, I think that is something that even where something simple can go a long way in recreating something that users find familiar and sort of can relate to.
Absolutely. Since you touched upon it, you're the deputy managing director at Microsoft Research India, and I'm super curious to know how is your day structured. I've never asked this question. I've done a bunch of these episodes. I've never asked this question to anybody, but I'm curious to know how your day is structured for some reason. So can you just talk us through it?
Yeah. To be honest, again, the honest answer is I don't have a super structured day. I basically uh, adapt to what is required, right? Like it takes. I mean, of course, I plan, but to a large extent, you can't over plan either, right? Although I'm deputy lab director, I do have some lab level responsibilities. I'm at my heart a researcher, right? So I do spend a significant chunk. I would say even the majority of my time on my projects, working with my colleagues. One thing I should say is, with HyWay and every other project I've done, I really have to thank my colleagues for being sort of the terrific people they are, right? Whether they're engineers, researchers, program managers, each of them has really contributed immensely, right? So in some sense, it's a joy to just talk to them and really learn from them, right? I may have this high level idea, but then a lot of the devil is in the detail, and there is sort of challenges. So a lot of my time goes in just talking to people in either in small groups, one on one, or larger groups, to understand where we are, what are the sort of blockers, what are the problems, what are the new opportunities. If you have done a deployment, for example, of HyWay or something, maybe we should talk about some of my other projects as well. We'll do that. If there are learnings from that, what we should do different. So in some sense, it's really what you would do as a researcher, right? But then, as a lab deputy director, I have responsibility. I mean, I manage a bunch of people, so in some sense, talking to them about their careers. And there are people who are not necessarily in my area or people who work with me. They are just researchers in their respective areas, but helping them broadly with, uh, advice and, career direction. Plus, other things for the lab, like, essentially things like managing budget, sort of managing priorities, if our CEO is visiting, how we should how we should use 45 minutes of his time, things like that. So in some sense, as I said, I don't try to overplan these things. I sort of take these as they come, but I do make sure that a significant part of my time goes into research, because that's really what keeps me going. I don't want to be a just administrator. I don't want. I would not enjoy that either.
Absolutely. Absolutely. And I'm just also curious to know, like you said, you're a big picture ideas guy. So let's say that you get an idea.
Yeah,
What is the process that you follow to really transcribe it? So it's flutterances or flutterings in your mind, wisps or
yeah,
some fantasy that is running.
yeah.
So okay, you understand it, you visualize it. How do you bring it out from your head onto something? How does that process work for you?
Yeah, yeah. Yeah. So then, actually, let me back up. I mean, I would say one thing that doing my PhD and writing my PhD thesis really helped me with. is in communication, right? One, when you have to write a thesis, actually, I've actually said this story in other talks. I'll mention it here. I wrote my PhD thesis, and Randy Katz, my advisor, had some comments, and I fixed those and so on. But there was another committee member in my thesis committee, a guy called Steve McCann. uh, he read my draft and he completely marked it up. Sorry, I'm giving you a long story here, but I'll tell you why.
That's fine.
And he completely marked it up. Literally every other word he marked up, right? Not because my grammar was wrong or spellings were wrong. It was that my writing could have been much more clear, much more precise, much more concise, right? So he literally, I mean, I think I have that marked up copy somewhere. I need to find it. It is like a treasure trove of, it really. So that was a wake up call. So anyway, so long story short, so that entire training process, including this sort of rude awakening at the very end of my PhD when I wrote my thesis and got everything marked up, I developed this habit of communicating clearly, right? So, for example, as I mentioned, the second month of the pandemic, I wrote this memo where I laid out some of these ideas and I sent it to some fairly senior people across the company, and they immediately got it and sort of what we were trying to do. Likewise, subsequently, I was able to communicate these ideas. So, I think to answer your question, and I've said this in talks. In fact, there was a talk I gave to IIT Delhi to a graduating class 5 years ago, where I said communication is super important when you're in research because you may have the best ideas in your head, but exactly as you said, unless you're able to get it out of your head and communicate it, it's not much use, right? So what I do is I write up these ideas. I also discuss these informally with colleagues, get their feedback, improve the ideas, and also hopefully inspire others to join the effort, right? And that's really what happened with HyWay. I had the ideas, but it really took off when a bunch of mostly young people got inspired during an internal hackathon that we were having at Microsoft and said, "Hey, this sounds interesting. Let's build it." Right? And so that's when the idea went from just being an idea to being something real, right? So I think, yeah. So the short answer to your question is, as a researcher, please work on your communication skills, both oral and written. Being able to explain things well, being able to explain things in a way that inspire other people, right? To you know either join your effort or just contribute ideas and sort of make your idea even better is super important, right? It's sort of the days of the lone scientist working in their own dungeon by themselves are long past, right? I mean, it may happen once in a while, but and even a lone scientist eventually has to get their ideas out, right? So they have to communicate. So I think communication, being able to talk to others and sort of be able to inspire others is, I think, it's really how I've been able to take this and maybe I'll talk about some other sort of ideas beyond the idea and turn them into reality.
Absolutely. And the other thing I wanted to even talk to you about, which from your project side, is the one that really got my attention was network brain. So it is something that is super fascinating from a technical standpoint, a performance standpoint. So I think before I ask any of those questions, I think for our listeners, if you could talk a little bit about what the Network Brain project is, it would be very helpful. Just give a, if you could.
Sure. Okay. So yeah, absolutely. So um, the yeah, so the genesis of network brain is the following, right? So if you look at uh, companies like Microsoft and some of our peers like Google and Amazon and so on, we run huge cloud businesses, right? Essentially, when I say cloud business, I mean sort of online services like Teams and like Office in case of Microsoft and Zoom is an example from other companies. Right? So the amount of infrastructure that is required to run these is just truly staggering, right? And so a natural question is when you're investing at that scale and you're spending money at that scale is, hey, can we get like a 1% saving here or 2% saving there? Because in terms of money, that is still very substantial, right? So that is sort of the quest for efficiency, right? In any system, and especially a system at scale, you want to make things efficient because otherwise the cost involved will be just prohibitive. So that's the high level problem. But the unique observation we made is that large systems have existed in the past, right? There were, so in the internet world broadly, there were the people who created applications and hosted websites. And then there were people who ran the infrastructure, right? The people, ISP networks who run the network, hosting providers that would provide sort of hosting space and so on, right? But there was a separation between the application owner, application provider, and the infrastructure owner or infrastructure provider. What we realize is that what's happened in the past several years is companies like Microsoft not only run this huge infrastructure, Azure in Microsoft's case, we also run some of the largest applications that run on that infrastructure. Office, xCloud, and Teams, and so on, running on infrastructure. So that's a significant shift from how things used to be. Right? Earlier, there was a separation between the application owner and the application and the infrastructure. Now, both of these are under the same roof. And so the question then is, what can we do that is new and interesting with efficiency in mind in a world where we potentially have access and control to both the application and the infrastructure? Right? Can we do joint optimization of application infrastructure? Right? So that was the genesis of this project. And then and by the way, it was not called Network Brain when we started with. I mean, we didn't really have a name. But one piece of advice I got from one of my internship mentors was, when you do something, especially in technology space, come up with a nice name for it, because people need a way to refer to it easily. Otherwise, the name Network Brain is newer, but the idea is something that we've been working for a few years now, which is what I just said, right? So under that umbrella, then we've been able to look at things like capacity provisioning, right? So at Microsoft scale, you have to build out new capacity, both compute and network, and especially network capacity. There's a long lead time. Let's say you need new fiber between Tokyo and Singapore. You can't get it overnight. You may have to plan 6 months, 12 months, 18 months in advance, right? So capacity planning and capacity provisioning is a big task. And so we were able to apply our ideas of combining application level knowledge and signals and infrastructure signals to optimize that and save a bunch of money. Uh, uh, Another example is server selection or server placement. So we are doing this call, let's say not this call, but let's say you're doing a larger call with multiple people. You have to decide where in the cloud to host it. Should you host it in a data center in Chennai, or should you host it in a data center in Chicago, right? So there are a bunch of considerations around latency, how far the users are for the server, cost, bandwidth, compute, all those things go on, right? We have done some work on optimizing that. So there are multiple such examples. So, but the basic sort of secret sauce, if you will, is a recognition that we have visibility now up and down the stack,
Yeah.
into interesting things that an ISP of the old day or a hosting provider of the old day could not do.
Yeah. Yeah, like you said, like because the stack is already you already provisioned for it to be vertical in the way that you want to process it. The way data actually moves becomes a lot more interesting when you decide to study it, right?
Yeah, but I should say that although conceptually everything is under the same roof, say at Microsoft, in practice, it's a large company, right? It's a
Yeah, it's still distributed.
right?
Yeah,
So you still have to deal with the tensions and the fact that this was developed kind of independently of that and so on.
yeah.
But so a lot of the engineering challenge comes from figuring out what is the minimal or the surgical way in which you can do this without sort of requiring everything to be squished together, because that's also not practical. Like, even if everything is part of the same company, you can't say, oh no, therefore everything is going to be one code base or one sort of thing, because things have evolved historically in certain ways. Unifying things is not that easy, right? So a lot of the challenge comes from thinking through how you do this with a light touch.
Yeah, absolutely. In fact, it just freaked me out for a second when you said that. Like, where, for example, like imagine you get everything under one code base. I was like, wow,
Yeah,
Microsoft has been there for so long.
yeah,
I'm sorry, I'm laughing, but
that's
it's
true.
insane to even think about it.
Yes,
So I think that's true. I think you have to be like you said, it has to be done with a light touch, and sort of also understanding where those new interventions are coming in from the other side, right? Where something's being developed independently. So how do you understand that? Hey, this is also happening. So how do you also bring
yes,
it in is super critical. And I
yes.
think
And by the way, a big part of this is, and we have done this in multiple projects under Network Brain, multiple efforts on Network Brain, which is bringing teams that are in different parts of Microsoft together, right? So you often had like a three-way collaboration, us and research working with an application team and an infrastructure team, right? And normally those teams may not have interacted as closely, but because we brought them together and we sort of laid out this idea that hey, we can do something better together, they were inspired to work together, right? So in some sense, that's been an interesting experience as well.
Absolutely. And, let's go into another project. And I think this is more close to home. It's called HAMS.
Yeah.
And, it's really interesting that, it's got a lot of interesting sensing work. It's got a lot of vehicle configuration related work that is actually going on in that. So can you talk a little bit about, the conception of where that came? You talk about coming back from the US and
Yes.
seeing India and how it happened. So
Yeah.
it's
Yeah.
over to
So
you.
actually, the genesis of this project actually goes back now, what, 15, more than 15 years. To 2007 is when I used to work with Microsoft Research in the US, and then I moved to the India lab, right, in 2007. And I often say, only half jokingly, that one of the first things that hits you almost literally in India is traffic, right? I mean, of course, you're from India, you're familiar with it, but when you come and see things in India after a gap, that's one of the first things that strikes you. So then the question then was, but that was around the time, and going back to what I was saying, technology trends, right? The early versions of the smartphone were there, right? So the BlackBerry and there's something called the HP iPac, which was perhaps
Yeah.
a leading edge smartphone then. The iPhone had still not been really
Yeah. Yeah.
yet, right? This is early 2007. So we said, okay, here's an interesting portable computing device. Can we use it to do something to tame traffic or to essentially help with the traffic problem, right? So the idea then was, okay, if everyone's got a mobile device or a smartphone in their pocket, can we use that to do sensing, and can we use that to then sort of use that sensed information to make things better, right? So that was the original
Yeah,
motivation.
and just for our listeners, I'm sorry for interrupting. For our listeners, I want them to understand that all this was being tried on phones which are not the phones of today.
Not at
Okay.
all. This is, and I don't know whether, I guess you don't have a way of showing visuals here, but if you go to our website, it was a project called Nerisal. And by the way, not to do too much of a digression, I have a bad habit of doing this, but we originally did this in 2007. We call it Traffic Sense. And one day, we got a cease and desist notice from a company in Israel saying, "Hey, Traffic Sense is our trademark. You can't use,
Wow.
you can't use
Okay.
it." So we scrambled, and there were three of us Tamilians on this project. We said, "Okay, let's do Nerisal." Right? Nerisal is like crowding or congestion, right? In Tamil, and the word "cell" kind of
Also,
connect.
yeah, it's a great wordplay. Yeah, yeah.
So this is a project, but we got the timing wrong, right? We did this piece of work. Academically, it was nice. We got a nice paper. 10 years later, that paper won a couple of Test of Time awards, so the community liked it. A lot of work was inspired. But as you said, the phones of that time were just not ready, right? Even a basic accelerometer sensor was not available. You had to take
Exactly.
the accelerometer and attach it and so on. So sometimes in research, or rather often in research and technology, timing also matters, right? So we could not scale up the system at that time. And then sort of we kind of lost interest. We said, okay, we've done this, written the paper, let's go and do something else. Right? So we kind of moved to something else. Almost 10 years later, in 2016, is when there was a lot of talk of IoT. So IoT was the new buzzword, right? Or Internet of Things. And I just thought, we did this thing in 2007, which never really took off at that time. Should we revisit that? And the reason to revisit that was twofold. One was, of course, phones or smartphones had become much, much better, a lot of sensors and so on. And secondly, AI was getting better, right? You could do something interesting with what you sense with these sensors, in particular with the camera sensors. And I realized early on that the camera-based sensing is going to be pretty important. Just to give you a very simple example, uh, if you think of something as simple as speeding, right? Knowing whether someone is speeding in traffic, you might imagine that a GPS sensor is good enough because it tells you speed and you can get speed and so on. But what really matters is your relative speed. The speed limit may be 80 kilometers an hour. If you're going at 90 and everyone else is going at 90, that is okay. That's actually reasonably safe. But if you if everyone is going at 90 and you're going at 60, you may be under the speed limit, but the relative speed, or often the opposite, you're going faster than others. then that's dangerous, right? To know relative speed, you need to be able to look around and you need to be able to see what others are doing, right? So that's a simple example where camera-based sensing we think is fundamental to actually having awareness of the environment. So anyway, so in 2016 we kicked off this project. HAMS really stands for Harnessing Automobiles for Safety. The idea was we'll take one of these phones, put it on the dashboard or on the windshield, and have it be like a virtual harness. We were thinking of fleets, right? So you're a fleet operator, you have 100 cars, you're sitting in the control room, you have a virtual harness there where you can keep a leash on each of your drivers, make sure that they're driving safely. And that was the original model. So that was the name, Harnessing Automobiles for Safety. And, that kicked us off, right? And so, yeah, so that's really what it was. And then, one of the other things I did, and going back to my earlier point, your colleagues and collaborators are critical, right? So I hired a colleague, Akshay Gambi, as an intern in 2016, and then I never let him leave. He did an internship, then he did a postdoctoral stint with us for 2 years, and then he joined as a researcher, and he's still with us, right? And so, and he and we had a bunch of other students, but really, he was really enthusiastic, really good, was able to take these high-level ideas and turn that into something working very quickly, and sort of and kept it for over multiple years, right? So, in some sense, a combination of having something that was a good idea at the right time and the right people is what really helped us uh, make this happen.
Absolutely. And I think one of the things that really acts as a through line between all these projects is this notion of impact. I remember while preparing for this episode, I watched a video where you spoke about what does the word impact mean to
Yeah,
you, and in a context of, I think, advising a lot of young students in that
yeah,
session. I think there was a lot of students there.
yeah,
And, I'm very curious to know that, we spoke about the problem definition side of impact, but can you talk about what impact is to you?
yeah. I can only talk about what it is to me because each one may have a full definition. And as I mentioned in this talk, I think you're referring to the talk I gave at 2018 at the IT Delhi convocation in 2018, is doing work that makes a difference and makes other people take notice, right? And this can take different forms, right? Even if it's an academic paper, a research paper, but a research team that is on the other side of the world picks up a paper, reads it, maybe even copies your ideas. That's okay. I mean, that's actually a form of flattery, right? Or builds on it, downloads your software. Or in the case of HAMS, which we just talked about, we built the system. When we created it, as I said, we were thinking of fleets and so on. But what eventually happened in the real world was we ended up automating the driver license tests. And today, like over 125, I don't know, even 130,000 license tests, right? 1,25,000 or more, actually, the numbers a bit dated. Automated license tests have happened on HAMS, right? So this is people who are not us, they're out there in the field, who are operating the system, other people taking tests with our system, and the overall system is benefiting, right? So that's an example of impact, right? So basically, things that you create that other people, makes a difference to other people, is valued by other people, is seen and used by other people, right? That's really broadly how a different impact, and it can take many different forms depending on what you're doing, right? And for me, that's definitely a goal. I mean, I would say we managed to achieve it in every project because sometimes things don't work out, and that's okay. But it is something that you want to strive for, right? Like in the case of HyWay, we've had many events inside Microsoft. Hopefully, eventually outside Microsoft, that will also use it, right? We want people to be able to benefit from what we create, and that is something that really inspires me.
Yeah. And given your position at in the industry that you're in Microsoft Research, one of the things I'm really interested in asking is, there's a lot of private research work that is actually going. There's a lot of academic research work that is also going, but somewhere there is a loss in translation to actually drive growth within India itself. I think academic research is great, but if it's not having the impact on, like you said, I'll frame it differently. If you have a certain idea or you have any kind of an output, and you can tell me if it's right or wrong, rather than being it like rather than it being somewhat of a theoretical exercise or a paper or something that's being read in the other corner of the world, if it's a package, if it's an SDK, if it's something like that can be accessed by somebody living in a tier 2 or a tier 3 city where they are able to actually expand the conceptions of what the original investigators were looking for. I think that is also a certain vision of impact. And I think, do you think a lot of research projects don't have that sort of tinkering edge to it?
No, I think this is an extremely important point. So thanks for bringing it up. I don't know whether it's necessarily the case that research projects don't have that, but I think the research ecosystem, and I think particularly in India, unfortunately, uh, rewards certain things more than others. For example, they will reward papers, and often you're on committees for awards and other things, promotions and so on. I mean, not inside Microsoft, because we do try to look at things more broadly. But just a few days ago, I was in a award committee where people tend to count papers, or tend to, at least sort of at the back of the mind, they say, oh, this person has so many of this. So once that becomes the currency, naturally researchers start optimizing for that. Once you've had a paper on something, they think that, hey, there's not much more glory to be had in making that thing real and building it in a way you're saying where other people can download it and use it. Let me instead work on the next paper, right? I said this problem is particularly acute, I've seen in India, because in India I think there is also, and I could be biased here, but one thing about me is I like to speak my mind, so let me just speak anyway. So is that people value intellectual work, and sometimes they look down upon working with your hands, right? So what I mean by that in the computer science context is coming up with the idea is the, or the algorithm, or the sort of clever thing is the valued thing. Actually building it is, that's just sort of boring engineering that someone else will do, right? I think that's a completely incorrect and completely counterproductive idea, right? And I shouldn't say this is universal, but I've certainly seen this, right? And I've actually heard faculty. Maybe there's a certain tendency like this everywhere, but particularly in India. If you look at the most successful universities and the most successful companies and things out there, they do exactly what you said. They come up with ideas and they actually build it, and they are able to scale it, and be able to make it available to everyone. Now everyone's using their stuff, and then they build on it, and they become customers, or they essentially get into it, right? So I think a lot of, in fact, just the other day, just 2 days ago on LinkedIn, I saw a video that had people like Elon Musk and Jeff Bezos talk about how designing something like the rocket ship or whatever Elon Musk is doing is important, but that is a tiny part of the whole thing. A big part of it is the execution, figuring out how they build this at scale and this and that, right? So a lot of it, I mean, like Edison said way back, right? 99% perspiration. Yeah. And I think we have to inspire people to do that by rewarding that, right? And certainly at Microsoft and Microsoft Research, we try to do it. Maybe we don't do it perfectly, but at least we try to do it. And I think the world has to do that, right? Every organization should really do that, because then the right thing will happen. Because if you reward people for just producing the idea and writing that up in a paper and then moving on to the next thing, then you have a lot of papers. But they're good. I mean, nothing wrong with papers, but they will not.
Yeah, I'm sorry for interrupting. I think I want to put a little distinction here also. I'm sorry, like I interrupted you, but
No,
it also depends on what kind of a paper it is. Is it really path breaking? Like, for example, if somebody was writing a paper like what Ivan Sutherland wrote as part of his thesis, right? Or if it's like an Alan Kay style thesis of a Dynabook or something,
yeah,
right?
yeah,
Okay, I understand that the compute and the components do not exist for those kind of products. So you have to have that as the intellectual pillar on which you're resting a lot of other things.
yeah,
But if that is also not happening,
yeah.
then I think we have to really question how we are even categorizing these things, is how I would
Right.
sort of
Yeah,
argue.
you're right. Exactly. So I think another way of putting what you said, which is I think a very valid point, is either you sort of go max on this or on that, right? Like what I mean is, you can't have a good enough paper that is not made real. If you just have a good enough paper, nothing wrong with that. See, every paper cannot be like Einstein's theory of relativity, right? I mean, you can't have something path breaking like that. A lot of ideas are good, but they're not like mind blowing. But what makes them big is then they get implemented, they become real, they become useful, they sort of change how the world does stuff, right? So you have to sort of do this, and yeah, you're right. You could once in a while have this brilliant thing which where the idea itself is worth disseminating by itself. Absolutely, you should do that. But I think this culture of making things real is super important, and that is really the key to progress. I think that's what, as a country, as an organization, as a company, whatever, that's what will get you ahead, right? Just there is all this famous thing about Xerox PARC, right? I mean, Xerox PARC invented a lot of ideas. They perhaps even prototyped it. They simply couldn't make it real in a real sense. They couldn't scale it, right? Rest is history, as they say, right?
Absolutely. So before we close, Venkat, thank you so much. I want to run you through a few closing questions, almost like a rapid fire sense, and
Mhm.
then we can formally close our conversation. So my first question is, what is one piece of advice you'd give your younger self?
Ah, I would say be even bolder than I was. I mean, just sort of take more risk.
Excellent. What are some books that have changed the way you think and engage with the world?
What are some books? I can't name one specific book right now. As I said, these encyclopedias at home really inspired me. They really sort of, as a kid growing up, in a world that was not connected, that was my window to the world, and it was fantastic.
Absolutely. What annoys me about other people that I sometimes do myself?
Uh, I don't know, maybe not listening sometimes. I mean, maybe just being too quick to jump to my ideas and my this thing. So if someone else does it to me, I will like it, and I'm sure I do it, and so people can naturally.
Understood.
Yeah.
Understood. What's your go-to method for overcoming procrastination or writer's block?
A deadline. It's not a go-to method, but yeah, like everyone, I too tend to sometimes procrastinate. I think just getting started. Right? I think one thing is a wheel in motion keeps moving, right? So get started, then things will, get a momentum of their own. So I think,
If you could travel 25 years into the future, what are the top three questions you want society to answer regarding the state of technology in society?
well, I think the first thing I would say is technology as a great leveler, right? I mean, it's sort of access to information today is so much better for even someone with modest means compared to what it was before. But can we, with AI and other things, make not just access to information, but access to a tutor and access to advice, and access to other medical advice, whatever. I mean, all the things people are working on today, but still early stages. In 25 years, we want to be. I imagine a world where, because of technology, everyone is at more or less the same common level, and so there's a great there's a great platform on which then people can then build, right? So that's what I imagine.
Okay, okay. Uh, if you could condense your life philosophy into one sentence, what would it be?
uh, Trust my instincts and go with it rather than you know worry about the herd and where others might be heading.
Absolutely. And what's a recent discovery or a piece of information that has blown your mind?
I mean, it's not one discovery, but really, like the rest of the world, I am also waking up to the potential of AI. I mean, I'm not an AI person. I've had some skepticism about not the abilities of AI, but whether uh, it is going to sort of make people, I mean, students and so on, lazy. In the sense that instead of trying to understand something, you let this figure out. You don't know how it worked, but it does the job, kind of thing. But I do realize that it is going to be a complete game changer. So I think I'm increasingly trying to see how I should be leveraging this even in my project, even though I'm not an AI person myself.
Understood. What's the most valuable piece of advice you've ever received and who gave it to you?
Um, I mean, yeah, maybe, yeah. I would say this it's not a direct advice I got, but this wake up call about my written communication during my PhD thesis, and the fact that this person marked up every other word really was a game changer. I think, even if I say so myself, my quality of writing had a quantum jump after that, because I started paying attention to how other people reading what I'm writing might interpret or misinterpret what I'm writing, right? And that made me much more careful in how I communicate, right? So
Absolutely.
that was a real wake up call.
Absolutely. And my last question is, what's one daily habit or routine that has had a profound impact on your life?
Um, I like to read something new every day and just sort of learn something about something new. I mean, uh, just quite curious about just learning about. Well, and by the way, new stuff doesn't have to be something newly discovered. It could be
Yeah, yeah,
new stuff,
absolutely.
a theory from 200 years ago that I didn't know about.
Yep.
Learning, right? So uh, that's what keeps my mind fresh. And usually, I try to do a bit of bedtime reading, just learning something new.
Absolutely. With that, Venkat, thank you so much for taking the time. It's been an incredible pleasure and an honor to have you on the show.
Thanks, Vignesh. The pleasure was mine. I really enjoyed the conversation and also really appreciate you taking the time to do the background research and come with really insightful and well prepared questions. I really appreciate that.